All right, guys, welcome back. Ms. Waysam, you want to continue?
Yes, sir, no problem.
All right, let us just rewrite the equation. So we would have
Adjacent over hypotenuse, which is
the cos of
the
cos of the angle theta would be, in this case, which side would be the adjacent? That would be BD
BD, sir. Yes, sir.
over the hypotenuse, which would be AB.
Yes, sir.
All right, so putting in what we know, we would get what?
15 over 50.
So cos of theta would be equal to 15 over 50.
Yes, sir. And when divided, we would get 0.3.
All right, so this will work out to be 0.3.
Yes, sir.
All right, where do we go from there now, Ms. Waysam?
All right, sir. We'd find sorry, I remember you call it, you know, that's something when you press second shift, second function and cost.
All right.
I did that and then enter 0.3 and I got 72.5. So I round that off to 73. So I got 73 centimeter.
All right, so our angle theta would be equal to the cos inverse remember now, when you're writing the inverse of a trig ratio, guys, you raise it to the power of -1. So cos inverse of 0.3. All right. So now you would have used your calculator to do that.
Yes, sir.
Calculation.
72.542. So that's round off to the nearest whole number, which would have been 73.
All right. So rounding off to the nearest whole number, we would have 73 degrees. All right.
Sir.
So theta would be equal to 73. Is that clear to everyone? Raise your hand if you're comfortable with what we have just done with this question. Not seeing any hands. Is it that nobody is understanding what we're doing here? Ms. Cabrera, are you okay with the question? Mr. Bartley?
Sir,
You'd want me to go back to it again, Ms. Cabrera?
yes.
All right. So I'm going to clear this and just walk back through the question for the benefit of those who are not seeing what is happening. All right. So what we want from the original triangle, which is the isosceles triangle, they ask us to find the angle theta. Now the angle theta is right here. Now in order to find the angle theta, we want to work with one of the trig ratio. Now in this case, we know that an isosceles triangle, if it is split from the apex angle down to the base, and the line is perpendicular to the base, then you can have two right angle triangles being formed. So when we split this down, we are going to use the left right angle triangle after we split it. So we split it down. So we take the left side of the isosceles. But remember, the base of the isosceles is 30. So if we split the 30 in two, it becomes 15. And so what we have over here is the left side of the isosceles triangle. And so this side BD now, because remember, B to the middle here would be from B to D. So that side BD will be half of 30. And so you get 15. And so now what we have here now is a right angle triangle that we can work with our trig ratio to find that angle. Following me so far, Ms. Caveira?
Yes, sir.
All right. So now what we do, we choose the trig ratio that suit this question. So we look at the sides that we are given. So we are given the side BD and we are given the side AB. Now we should ask ourselves the question, what relationship the given sides have with the angle that we're trying to find? So you see that the side BD would be the side adjacent to the angle. And we already know that the longest side AB would be the hypotenuse. So now which of the trig ratio uses the adjacent side and the hypotenuse? And so that would be the cosine. All right, so we can use the cosine ratio based on how these two sides are related to this angle. So we would write the cosine ratio based on this angle. So we would find the cos, and if we are using the vertex to represent the angle, it will be the cos of the angle B and then now if we are writing out the ratio in terms of the side, we know that BD is the adjacent side, so we write BD over the hypotenuse, which is the side AB. Following so far, Ms. Cabrera?
Yes.
All right, so now what we are going to do now is put in what we have in terms of values. So the angle that we're finding is theta, so we're going to replace the angle B with theta. So we're going to find the cos of theta. So theta is now the angle. And then now, in terms of the side BD, we got that to be 15. So we'll put 15 over what we get for the hypotenuse, which is 50. Now, because we are trying to find the angle, what we want to do is to write our fraction on the right side as a decimal. And in order to do that, you divide the numerator, which is the 15, by 50. With your calculator, you'll get a decimal. Now, Ms. Wason had calculated that to be, how much you had it, Ms. Wason?
0.3, sir.
0.3. All right. So 15 divided by 50 becomes 0.3. All right, so our next step now is to find the angle theta. Now notice that this is the cos of theta. No? This is not the angle theta. And in most cases, we would not have our theta in terms of a decimal, 0 point something. So in order to find the angle now, so it's the angle theta that we are concerned with. So we have to now find the cos inverse. So if you notice that the cos, that is the cos symbol that we have beside the theta, we remove it to the other side and raise it to the -1. So we have cos to the -1. And then now we write back the 0.3. And what that is telling us is that we are finding the cos inverse of 0.3. Now, this is something that you have to be able to do with a calculator. So if you're using a scientific calculator, you would have to press the shift button and then press back the cosine, put in your number, which is 0.3, then you press equal, and then that would give you the angle. Now, it depends on the calculator that you're using. Sometimes you may press the shift button. Well, in most cases, you will have to press the cos. After you press the shift button, you have to press the cos, and you put in the number, then equal. All right, so once you have done that, the angle that we got based on Miss Waysom's calculation is what? What was it? What was the calculation again? What's the angle?
72.54, sir, round off to 73 to the nearest whole number.
All right, so rounding off 73. Angle
Yes, sir, centimeter.
73 degrees.
Oh, yeah, degree.
Is that clear to you now, Miss Carrera?
Yeah.
Okay. Is it clear to everybody? Raise your hand. Let me see who is understanding. All right, Miss Carrera is understanding. Awesome. Who else? Mr. Bartley? Miss Green? Oh, Miss Green is not here. Mr. Lamar, are you understanding? All right.
Yes, sir.
Okay. So, all right. So I'm going to clear this and move on. All right. So based on our calculation, our angle would be 72.5. Rounding it off to the nearest degree, we'll get 73 degrees. All right, moving on now to the tangent ratio. Now, can somebody state the tangent ratio for me, please?
Opposite over adjacent, sir.
All right. Everybody agree with Ms. Waysom that the tan of an angle is the opposite side to the angle over the side adjacent to the angle. All right, so you must be intimately familiar with these ratios to know which one is which. Because in most questions, you won't be told which of the ratios to use. You will have to look at the angle and the sides, and based on how those sides relating to the angle, then you decide which ratio will work. So bear that in mind, guys. In a question, you won't be told what ratio to use. You have to decide which one will work. All right, so here we have the first example for the tangent ratio. And so I will just give you the opportunity to try to work out this question, and then you can, whosoever want to, can walk me through the answer. All right, so I'll give you about 3 minutes to work this out, and then somebody can walk me through the answer. So in this question, they are saying we have to find the length of the side AB. So I'm just going to label that side X, right? And you would have known the side AC, and you know the angle at C. All right, so with all of those information now, work out, go through the process and try to calculate X for me. I'm giving you 3 minutes to do that. All right, is anybody ready to walk me through this question now? Who's ready to walk me through this question? Ms. Cabrera, you think you want to walk us through this question?
Yes, sir.
All right. All right. Go ahead then, Ms. Cabrera. Tell me what to do. First, state the tangent ratio based on the angle that we are working with.
Of tan angle
All right. So
equal
the tan of which angle?
AB over AC. Wait,
No,
42.
use the capital letter at the angle. Use the vertex.
Angle C.
So we're working with angle C. So the tan of angle C is equal which side over which side. Use the letters in terms of the side.
So AB over AC.
All right. So we have AB over AC. All right. Is it AC? Right. Good. All right. Continue, Miss Cabrera.
Then I have tan 42 degrees equals X over 40.
Tan of 42 degrees is equal to X over 40.
Oh.
All right. What next, Miss Cabrera?
I just made 40 the subject.
All right. In this, remember, you're really making X a subject. So X has to be by itself on one side. So we want to move the 40. Where are we going to move the 40 to?
At the front. So it'll be 40 times.
Which side of the equation, left or right?
So the left.
All right, so we're going to have 40 tan of 42 degrees. And that's going to be equal to X. What next now, Ms. Cabrera?
40 degrees. Wait, no, 40, just 40 times. And then I calculate tan 42.
All right, so what you get tan 42 to be? Anybody? Give me to 3 decimal places.
0.900, sir.
0.900. That's it?
Yes, sir.
And that would be equal to X. All right, so you can go ahead and do the calculation now and for X. So X is equal to what? Multiply 40 times 0.900. What you get? Ms. Waysome, can you assist us? Because I don't know if Ms. Cabrera is working with a calculator.
36, sir.
36?
Yes, sir.
All right, so that would be 36, and we're using our units as in the question, so it is 36 millimeters. All right, guys, everybody clear on this one? All right, so I'm going to clear what I have on the screen and then move on to the next example. All right, so we have tan 42 equal to AB over AC. We have tan 42 equal to AB over 40. And we have 40 tan. Well, there's an error in this line down the bottom. This should be 42. All right, so our answer will be 36 millimeters. All right, I need to fix that after the class. All right, guys. All right. So here now is the next example. You can go ahead and try this example, guys, and then whosoever work it out first will walk me through the question. All right, guys. Giving you about 3 minutes, just the same as before. Is there anybody who would like to walk us through the question? Let me give you a little bit more time. All right, guys, anybody ready to walk me through this question? Ms. Cabrera?
Sir, should my answer right?
All right. Anybody else finish? Mr. Lamar, you finish? Ms. Wasom, Mr. Bartley? How are you making it, Mr. Bartley? Are you following?
Sure.
Oh, you finished, Mr. Lamar?
Yes, sir.
You want to walk us through this one?
Yes, sir.
All right. Write down the ratio for me, please.
30 tangent.
All right. So we're dealing with the angle. The tan of which angle? Give me the capital letter.
So AB.
No, not
On
this
C, on C, angle C.
angle C. And
Equal
that
to
equal to
AB
AB
over BC.
Okay, what next? Continue.
Okay, so now replacing with actual values. So tangent of angles 38 degrees is equal to 32 over x.
Okay, continue.
So now I want x by itself.
Mhm.
So first we write x on the left side. Equal to 32 over 38 over tan 38 degrees.
All right, so working out tan 38, what again?
So tan 30. So I got tan 38 equals to 0.781.
All right, so what you get for your answer now for X?
Choose the nearest whole number.
Yeah,
I got 41.
and so our unit would be 41
millimeters.
All right, did anybody else get that answer? Raise your hand if you got that answer. Ms. Wilson, Ms. Cabrera. So Bartley, I don't know if you're just there passively, but I'm not hearing anything from you. All right, guys, so everybody's comfortable with what we're doing. Ms. Green, are you comfortable with what the question we just worked a while ago? Ms. Green,
Sir, I just came back. I don't know what is going on.
Okay. All right, so let me just walk you through this quickly. So we're now working with the tangent ratio, all right? Can you recall what the tan ratio states, Miss Green?
Opposite over adjacent.
Okay, good. So we're given the angle C, which is 38. We are asked to find the side BC, which we label X, and we are given the side AB. So when we look at these two sides, the relation they have with the angle at C, we see that the side AB would be the side opposite to the angle C. Do you agree with me on that, Miss Green?
Yes, sir.
And then the side BC